Hi everyone. The project name is Air Quality Index. So in this project, we will monitor and predict the air quality for the environment planning and the public health management. So in this project, we are using deep learning based approaches to predict the air qualities index. We will categorize by using the real-time environment pollution data. So here we are using LSTM and DNN. So LSTM is nothing but long short-term memory and DNN is deep neural network. So this is deep learning algorithms. So here we will classify the air quality into six categories like good, satisfactory, moderate, poor, very poor, and severe like that. So based on our inputs, it will predict whether the air quality is good or satisfactory, moderate, poor, very poor, and severe. So in this, our target variable will be as AQI bucket. So this will be derived by mapping the pollutant averages. In inputs, we have pollution minimum, pollution maximum, and pollution average that will be derived and mapping to the AQI bucket. This is our block diagram. First of all, we need to collect the data and then we need to do pre-processing. After that, we will train the model. So this is our two algorithm, LSTM and DNN. After that, we will do evaluation. At last, we will predict what types of air quality index it is like that. So you can see the result how it will be. So this is our input like country, state, city, station, pollution ID, pollution minimum, maximum, and average. So if you enter the data, it will predict the prediction is good or average, moderate like that, it will predict it. So this is our training code. So first of all, we need to import the required libraries and this pandas numpy for the data manipulation and matplotlib and cbound for the visualization and this TensorFlow and Keras to build our model like dense LSTM. And then this sklearn for the pre-processing, and we will split the data set into training and testing purpose. And then job lead for to save the models. So first of all, we need to load the data set. So we have two data set that will be merged into one thing. So that will be stored in the station lane. So wherever we are seeing the white space, right, we need to remove that. So by using strip function. So whenever you are collecting the data, every data will not be going to use our project. So we need to drop unnecessary columns. So only we are taking what are the columns we required for our project. So here we are dropping the unnecessary columns. So we are mapping AQA bucket. So good, satisfactory, moderate, and poor, very poor, severe. So how this mapping is happening means we are merging that three things like average, pollution minimum, maximum. So based on that, it will get one value. So based on that, it will be good, satisfactory, moderate like that. And so we need to do the label encoding, right? So moderate, satisfactory, very poor. Further, we are setting like index 0, 1, 2, 3. This is the label encoding. After that, we will drop the unnecessary in place equal to true, which means if any columns empty or unmissing values means we will drop that. And then we will select the features and a target. So we accept this AQI bucket. Every column will be as the feature and this AQI bucket will be our target. So we are using SMOT. SMOT is nothing but it will balance our label like data we have, right? So it will balance our label. So this is SMOT balancing like X and Y. We can see here fit resample of X and Y. So X is feature and target. We are balancing our label. So after that, we are doing normalizing features and saving the scalar. So by using this min-maxer function, we are doing the normalization, which is nothing but it will convert everything into the values of between zeros and ones. So after that, we are saving it. And then we need to split the dataset for the training and the testing, right? So for testing, I'm taking for the 20% and the training, we are taking for the 80%. So first we need to build our model. So we have two model, right? LSTM model and DNN model. So first we need to build our model. So this is for the input. We need to reshape our input. So it will convert to the 3D for the input like LSTM, Xtrain and Xtest also. So by using this function, squintl function, we are initializing our model. So this is main purpose because whatever the layers are coming like one by one, it will store here. So input layer and LSTM 50 and dense we are giving 26 and activation as a relu and dense 10 at last that final output 6. So we have 6 class, right? Like good, very good, moderate like that. So this is the final output. Activation we are taking as a softmax, which is nothing but it will search for the probabilities. So which is giving that highest accuracy and it will display our good prediction. So we need to compile that model. So we are using optimizer as Adam and loss is equal to sparse categorical asymptotic. So which is nothing but this is for the multi-class purpose. And then we are fitting. So by using this fitting, we will use for the epochs 10 and batch size 32 like that. So same thing for the DNN also. So after that, we will do for the evaluation and we are saving the model. In evaluation, we will print its accuracy. Same thing for the DNN also. By using this 20L, we are initializing our model and this is number of layers. Final layer will be 6 and we will compile and then evaluation and saving the model. At last, we are displaying its accuracy and the losses for the both LSTM and DNN. So this is the testing code. So we need to import the required libraries, Tkinter and Keras, NumPy, Pandas like that. So we saved two model, right? LSTM and DNN. We need to load that here. After that, we need to load scalar like EAQA scalar dot pkl. We will be saved in here. So you can see that we are saving as AQI scalar.pkl, right? So we are say, loading in test. After that, we are defining our function like get user input. This is the to get the input from the users, and we'll do for same thing label encoding. So this is our predict function. First, it will get the user's input, and based on our model trained, right? So based on that, it will predict whatever part quality it is like that. So we'll go for the web pages. So this is our web pages ad quality detection. So here you can see that login, register, contact about prediction. So first of all, you need to register. Once if you register, you can directly log in. So this is about page, like what are the models we are using and what are the technologies we are using in our project. It will be displayed in our about. And then contact, if you have any queries, you can contact this. So this form will get by our mail and we will contact back like that we are keeping here. So this is our prediction page. So here you can enter the inputs and based on that it will predict our outcome. So here you can see that for prediction result is good. So I have taken this first row of our data set and it's predicting our prediction result is good. So we have n number of rows in this. So you can check other rows.